Next, we will work with ur robots programming and controlling by MoveIt. To program ur robot, we should include some libraries in CMake. In CMake, you should include MoveIt. Okay, I will. In the Catkin, in the file package part, you should include interact markers able to display the cameras and others. It's like an obstacle object. Yes. And include MoveIt core, MoveIt cross planning, MoveIt cross planning interface, perception, and the others. Okay, there's so many. Then we include in the libraries. Okay, and when you write a new note, you should add a target build here. We do it quite many times these days, so I will not talk about that. And in the packet XML, you should include some new package by build depend and execute depend. You can see it more clearly in the GitHub file. So go back to the ur3 sense.cpp. In this file, we will add the collision objects to the environment. It is not the only simulations environment, because when we work with real robot, this collision objects still exist. Like we describe these things in the real world for programming, and it is sold in RV's screen. And here this is the display the crowd where the robot stand up, and this display the camera positions. And because these are configured as collision objects, so when the MoveIt generate the moving path, it will avoid these objects. And this is for like we also move the cameras up as the initial positions. And we create new files as ur3 creepers. This is for controlling the ur robot. Here we define the functions to control the robot. You can use a topic or service, but if you use the topic, it's like for example, we have 3 or 4 pruning points. So if we use the topic, we cannot detect when an action's finished. So I decided that we should use a service. Okay, service here. Service will receive the positions from our program and control the robot to the target point. And in this example, we use to post service methods. it includes x1, x2, y1, y2, z1, z2. It is the first position, near position, and true position, x, y, z, and w. Here is the rotations. Go back to our creepers. Okay, go back to here. Take a look at this function. We will receive the position through the request service, and we get the position x1, x2, y1, y2, and z1, z2. Firstly, we will get the position of the arm group. It means the robot arm, because the robot arm and end effector is our creeper is separated into two groups. First is the arm group, and the second is the creeper group. And we detect the current position of the arm group, and then we set the new position is the first position, post 1. And this is the meaning that the plan, we generate a plan, and if it is successful, we really execute this plan and to the close position, and then we open the creeper, and then we move to the second position, and then we close the creeper as demonstrate for cutting action. And then we open the creeper, move to the closed position, and then finally move to the initial position. That is how we do. And the open creepers now we are using for the simulation. So it's different when we use the real creeper GR2. It's different. So the open creepers here. Okay, now we will talk about how we publish these, how we get the close and true position for performing pruning action. And the last time we have detect the cut point. Now we are writing more one more function is that publish the cut point to controlling programming. So the cut point was stored in the list cut point here, and we we will go through each item of this list to call the service for moving the robot and prune the leaf. How can we detect the rotation, the pruning pose? Not only the position we have detected, but the pruning pose we did not detect. So this function will detect the rotation of the end effector. So I will show you the ideas how we do that. Wait a minute. I copy an image here. Okay. Okay, this here. So the idea is that we will after we find the cut point, after we find the cut point here, we will detect the vectors of the petals, and we also detect the camera vectors is from the camera to the camera to the camera to the pruning point. So we have a V1 and V2 too here, and then we finding the V3 by cross product to this perform the cross product action of these factor of these two vectors. We have a result of vector 3s here, and next we will find the it's not really opposite, it's not the V3, the minus V3, because it has the opposite direction. And then we perform cross product action with V1 and V3. We have a VE here, and V1, V2, and VE is performing the OX, OY, and OZ of the end effector. That is the rotation of the end effector. Okay. So that is the idea of this function, and we go back to the programming, and this function will finding the positions, and we have the rotations here. We have a P1 and P2, point 1 and point 2, and we call the service with the values of P1 and P2, and this program will call the moving functions in this 3D creepers here. To call this function. Now I will run it in simulation environment. I will launch the ur3 in Gazebo, and I will launch the MoveIt. The app is so we have the avis now. Okay, and then I will run the node to create the camera and back and the background. So you can see the cameras here, the crowds here, and robots were moved at the initial position by this command. And then I will run the controlling node by this command run raw image back ur3 clipper, and it's waiting for like the calling service. Now I will render our program to find the cut point, the pruning point, and publish to and call the service to control the robot arm. Okay, we also published our pod cloud to the browse topics. It is the the name is plan mapped. Not plan map. It is the plan cloud here. Okay, now I will start the camera. We can see that our base lamp beginning to define the position, and our pod clouds are building, and you can see it's in here. Okay. And now we will detect the position. You can see here we have a cutting position is the 0 point, just to get for easy to look. And now we will call the pruning action by press number 3. The programming will calculate the rotation matrix and call the pruning action, but it cannot. Why? Unable to show. I will start again. Why? Okay. Oh, that's why the first time we cannot move. It generates a very complicated path. Sometimes it's really complicated. Unable to solve. Okay. Because the pruning path is so like close sometimes. So I will try to detect again another position by running again this program. I want to move it in the post position, so I will stop this and render sense again to set the robots to initial position. I will run this again. Okay, I will running the control again. Okay, clippers, yes, I will stop to find the cut point. Okay. Okay, after stop, I will move the camera, the robot arm to this cutting board positions. It's not. It depends on the generator, the path. Okay. Oh, it looks very complicated. Okay, this looks good. Okay. It's just a go back and move to the initial position, to the original position, but sometimes it's not work. Okay. Anyway, it's can move to the first position. That's good. That's how we control the robot arm, but sometimes generate path is not easy. Sometimes it can run, sometimes it cannot, and maybe because this plant we set up at like close positions, so sometimes it's difficult. Okay, that's our example.